Good day, grade 11 electrical technology students. Today we are going to focus on the NPN transistor under semiconductor devices in electronics. Okay, by the end of this lesson, you must be able to explain what semiconductors are and their types. Describe the structure and function of an NPN transistor. Understand how an NPN transistor operates in a circuit, and also identify real-world application of NPN transistors. What are semiconductors? Semiconductors are materials with conductivity between conductors and insulators, which means they are not good conductors or good insulators. They are between good conductors and good insulators. Common conductivity materials are silicon, Si, and germanium, Ge. Their conductivity can be increased by doping. Types of semiconductors. Number one, we have intrinsic semiconductor. These are pure semiconductor materials. They have limited conductivity. Number two, we have extrinsic semiconductors. They are doped with impurities. Two types of extrinsic semiconductors are N-type with extra electrons or negative charge carriers. We have P-type with holes or positive charge carriers. PN junction formed by joining P-type and N-type materials creates a depletion region, allows current to flow in one direction, foundation of diode behavior. What is a transistor? A transistor is a three-layer, three-terminal semiconductor device which is used to apply or switch electronic signals. Two main types are NPN and PNP, but today we are going to focus on NPN transistor. Here is the NPN transistor structure. It has three layers: N-type, P-type, N-type. Its terminals are emitter, releases electrons, then base, thin layer that controls the transistor, and we have the collector, which collects electrons. How an NPN transistor works. We start by basic structure and terminals. Emitter, heavily doped. It emits electrons into the base. The base, thin and lightly doped, allows some electrons to pass through to the collector. Collector, moderately doped, collects electrons from the base. Biasing for operation. To operate in active mode, used for amplification, the transistor must be biased as follows. Base emitter junction, forward biased. Base is more positive than emitter. Number two, collector based junction, reversed biased. Collector is more positive than base. How it works. 1. Forward bias or base emitter. A small voltage, typically approximately 0.6 volt for silicon, is applied between the base and emitter. This allows electrons to flow from the emitter into the base. Electron flow. The emitter injects a large number of electrons into the base. Since the base is very thin and lightly doped, most electrons, 90% plus, pass through into the collector. Then current flow. Base current. A small number of electrons recombine with holes in the base, creating small base current. Collector current. Most electrons go to the collector, forming the collector current. Emitter current. This is the total current equal to collector current plus base current. Formula is emitter current is equal to collector current plus base current. Current amplification. The transistor amplifies current. controller current is equal to beta times base current, where beta is the current gain, typically between 20 to 200 for most NPN transistors. NPN vs PNP. In an NPN transistor, electrons are the majority carriers. In a PNP transistor, holes are the majority carriers and the polarities are reserved. Applications. Switching. When the base is fully on, the transistor conducts from collector to emitter like a closed switch. Amplification. A small current into the base controls a much larger current from collector to emitter. A transistor is a switch. In its off state, no current to base and no collector current. And in its on state, small base current, large collector, then this emitter current. It is used in logic circuits, microcontrollers, and switching applications. Then we have logic circuits used in TTL, transistor logic gates, AND gate, OR gate, NOT gate, NAND gate, etc. NPN transistors act as both switches and amplifiers to build logic operation. Then we have signal modulation. NPN transistors are used in AM and FM transistors to modulate audio signals onto a carrier wave. Then we have voltage regulation and power management. It is used in voltage regulator circuits, such as patch transistor in linear regulators. Control voltage levels in power supplies. Then we have oscillator circuits, used to generate oscillation signals for clocks, radios, and microcontroller systems. Combine NPN transistors with capacitors and inductors for oscillation. In summary, semiconductors are crucial in electronics. NPN transistors are common and versatile. They can operate as switches and amplifiers. They require proper biasing of junction. Students, this is the end of our lesson. Thank you for being part of this lesson, and if you have any questions, you are free to ask in the comment section.